Let's look at the solutions to these problems from this quiz. All right? Same problems on two different quizzes, just the order were scrambled up. So this quiz is the yellow quiz, and so the same problem appeared on the blue quiz is number 7. And what I'm going to choose to do is I'm going to choose to switch these terms around. Okay? And how I'm going to switch those terms around is as follows. I'm going to say I've got this x squared y term, and I want to join up some other terms with that so I can pull out some common factors. Okay? The greatest common factor, which I think is going to be afforded if I write this x, y, z term next. Okay? Then I got the remaining terms, which are the negative 2z squared and the xz remaining. Sorry to make that z that way. Now I'm going to split it in half, take out the common factors. In the first two, I've got an xy coming out, and that's going to come out as x minus 2z. In the second two, I'm going to pull out a common factor, and I want to pull it out as a negative z, and that's going to be a 2z minus x. So now I can say, well, I wish this grouping and this grouping were the same, and they can be. So that can be x minus 2z at the expense of pulling out a negative, making that plus z. Okay? xy, x minus 2z. All right? Common factor is x minus 2z. Common to xy plus z. That's factored now. Number 2. I gave you a little heads up on that to look for it. And so therefore, you didn't look at this one as I directed you to. I didn't bother to give you any credit if it was wrong. It was wrong, it was wrong. So here's what I did. I just pulled out a negative from this grouping because I saw that there was an x minus a in there. So that becomes a common factor, x minus a. And that's common to the 64 x minus a cubed, okay, minus 1. Now, this is not done because this is difference of cubes, but I'm going to let you finish that one out because just for the sake of time, okay? All right, and that one was also on the other test as number 8, right? Next we go, okay, we got here. There's x squared all by itself. Here's y terms. They're going to come together. That is the first off. I want to remove that negative so I can group them. So it's x squared minus, and I have y squared plus 4y plus 4. Okay? And so that becomes x squared minus, this is going to factor as x plus 2, the quantity squared. Now I have the difference of squares. Okay? I have the difference of squares, and you should be able to factor it from there. Again, I'm going to leave that one for you from that point. Okay? Here, all right, we're going to see that we can cluster this first grouping and take minus 36. Okay? And so that's going to be 5x plus 2y, the quantity squared, minus 36. There you go again, a difference of squares again, a difference of squares again. It's the same thing as the previous problem, okay? A difference of squares. Here, we've got a common factor of h plus 1 to the third power. That's the greatest common factor. That's going to be common to 100 minus the quantity h plus 1, the quantity squared, okay? This comes down, this is difference of squares. Once again, a difference of squares. Here is the difference of squares. 7, this is like a squared minus b squared. Just like this is a squared minus b squared. 7x minus 2y plus 3y plus 5x. Make sure you parentheses aren't so vital there as they're going to be in the next grouping. 7x minus 2y minus, there's where I'm going to watch my 3y plus 5x. Okay, that problem again, that appeared. So these are my two groups. I'm going to condense them down to 7x and that should be 5x, mind you. So that's 12x, and that's negative 2y and 3y, so that's plus 1y. 12x plus y, and then this grouping is 7x minus 5x, so that's 2x, and negative 2y minus 3y is minus 5y, so that is now factored. Okay, let's finish it up. This one was probably the most challenging problem. Number 3 on the other test. Okay, I do have cubes, and they should stand out as a difference of cubes right there. That's 8 cubed plus, or rather sum of 2 cubes, 27b cubed. Then I have the remaining terms plus 9a squared b plus 27ab squared. This problem was fun. And you probably don't agree, but this is a sum of cubes, so that's a plus 3b, okay, times a squared minus 3ab plus 9b squared. And from the second grouping here, I got a 9 that's common, so I'm going to pull that out. 9. I've got an a and I've got a b that's common. So 9ab is common to a plus 3b. A plus 3b is common to both. A plus 3b. A plus 3b common to a squared minus 3ab plus 9b squared plus 9ab. Okay, I've got some terms to tie together here. A squared plus 6ab, that's what's going to happen when they come together, plus 9b squared. I've got this a plus 3b coming down. Lo and behold, this is a perfect square trinomial. That's going to factor a plus 3b, the quantity squared, times this a plus 3b, collectively giving us a plus 3b, the quantity cubed. Who would have thought? There you go. Okay? This is a perfect square trinomial. It goes into 3m plus 2p, the quantity squared. Okay? Here is something as factorable as x squared, minus 16, and x squared minus 1. And those will subsequently factor again. X plus 4, x minus 4, x plus 1, x minus 1. Here's a square, here's a square, here's a sum. 5y minus 2, 2y minus 5y. Let's reverse that to read 5y minus 2 at the expense of the negative offsetting out front. Okay, then we have x squared, remaining term, 5y minus 2. Now, 5y minus 2 is common. Common to x squared minus b squared. That's the difference of squares. Again, once again, x plus b, x minus b, and this binomial 5y minus 2. So there it is. That's the test in its entirety. A lot of difference of squares. A lot of difference of squares. Of course, I did not solve some of these out all the way, but you should be able to do that. Okay? There you have it.